Hello, I'm Sean. I'm a developer advocate for IBM. Today I'm going to talk to you about bottomless hard drives with Node.js, views, and object storage. Hopefully the content will make up for the really verbose title. So before we jump into technical details, because I know we love all that, I'm going to talk a little bit about why I thought it'd be fun to work on this. About a year ago now, I was very, very privileged and a bunch of my colleagues to be invited to Gonville and Caius College at Cambridge for dinner to meet with academics and technologists and people that were interested in everything under the sun, basically, about computers and IT and all these things, which was great. And while I was there, I was with my colleague, Ross Cruikshank, all-round cool dude and a fellow developer advocate for IBM. And we started talking about low-powered, long-range radios and how the arrival of the 5G network may replace some of the use cases for things that LoRa is commonly used for now, because part of our day jobs is being giant IoT nerds. And while talking about 5G networks, one invariably comes upon the topic of the promised network speeds. You know, if you look at the Wikipedia 5G article, the promise is 1.4 gigabits per second, which when you compare that to modern 4G networks, the best you're going to get is 50 megabits per second at a push, which is incomparable, basically. But here's where the conversation started getting interesting. We started thinking about how those network speeds are starting to approach the speed at which your local hard drive can read and write things to and from as is needed. And so can we imagine a time where with such network speeds, we can replace almost entirely a local storage system with something based in the cloud? Now, we live in a time where technology comes on in leaps and bounds. When I got my first computer, a 4 gigabyte hard drive was horribly expensive, and 4 gigabytes, which I'd never fill up, but I did, and now I need a bigger one, and this is 512. And speaking of my local hard drive, this is the hard drive in my Mac. Now, this is a 15-inch MacBook Pro. I think it's fair to say that a lot of JavaScript developers have this kind of laptop, so I think it's fair to look at the stats of this drive and compare it with what 5G may well promise. God, you're all up there, aren't you? That's kind of cool. Right, so this drive, according to userbenchmark.com, can write things like large files, like one big file, at about 477 megabytes per second, which is pretty cool. Now let's compare those two numbers, 1.4 gigabits per second versus 477 megabytes per second. Now, before someone says it, I know those are two different things. If you were to compare that, if you were to convert the gigabits to a read or write speed, it would be about 160 megabytes per second. So your SSD with the near future technologies is still way faster than the network will offer, but it's approaching something that may well be usable, which is kind of cool. And so after this conversation, I started thinking, can we do this today? What do we have available to us in the tech stack, in our computers? Is it possible to trick an operating system into thinking that, hey, this is a hard drive, but it's not, it's in the cloud, without treating it differently? And even if we could do it, is it practical? Your super fast internet in your home is probably way slower than what 5G is offering. I work in central London. I live in Deptford. I have the slowest internet speeds in the UK, basically. Netflix 4K? Not going to happen. We'll get to that bit later. But, to give you a sense of what I'm working with, this is my home Wi-Fi, and this is my coffee shop Wi-Fi, because I work remote. It's not good enough for me to do things like video production or even opening PowerPoints, which is not what this is doing here now. But think about it. We can still write the software that can still take advantage of this sort of technology when it comes to the fore, when it comes eventually. If you'd said to someone back in 2005, hey, we're going to launch an online movie streaming service, everyone would think you were mad, but that's what Netflix did, and the internet was 2 megabits per second back then. Blockbuster was like, nope, that's not going to be a thing. DVDs are the future. Wrong again. So I started looking around. What kind of solutions are out there now? This is not an obvious thing, but who's got these sort of things? And invariably, when talking about storage, one comes across Dropbox. But what they do is very, very nice. They offer a client for Linux, Mac, and Windows, and they observe a file system, they see when it's changed, and then they sync that to the server. But that feels a bit like a cheat to me. So I thought, is there a way to really hook into what's going on with your file system and offset that to the network, be network bound rather than disk bound? And so I went looking. This is a real picture of me looking around for alternatives. When one's dealing with this kind of low-level system interface, You're looking at like writing a device driver. You're looking at, getting down into some kernel code and saying to your operating system, hey, I'm native, I want to do this thing, you can do this thing, let's believe it together. What? I don't know about you, but I've never come close to writing anything that deals with a kernel or anything like that in any sort of way. Device drivers are things that other people deal with. I'm a Node.js developer. I live and work in user space. That's my whole kind of jam. So end of the story, right? Presentation over, see you later. I waited 5 seconds there for the bit, but it was worth it. Right. No, whilst wandering around, I came across this. Fuse for Mac OS, which stands for File System, F in user space. Use, Fuse. And what this does, amongst other things, is allow you to take a directory on your system and have your computer pretend that it's a hard drive. And you in your user space, with your application, can hook into those events and say, hey, you know how you want to like write a file here? Let's not do that. Let's do this other thing instead, which is great for me, because now I can start writing a little bit of JavaScript. Also, as it turned out, this was already on my Mac. It doesn't come pre-installed, but I needed to mount like an X4 file system, which is like popular with Debian, and I do a lot of stuff with Raspberry Pis. And so it was like, cool, I'm ready to go already. So just need to now find something in JavaScript that like lets me do these things. So I looked around, and I was like, well, what kind of language can I write this in? C++? No, we're not going to do that. We're not going to do that, Go, very modern language. I love it. I'm learning it. It's something that I really want to do good at. But I don't want to spend time, learning Go as well as trying to write this thing that I'm trying to prove can work. So again, yeah, no, sorry. How about Python? Great support. Python is as old as me, which is a horrifying thought now I think about it. But at the same time, I hate the modular ecosystem. Like, what the hell's going on there? What the heck's going on there? Sorry. So again, nope. So, naturally, we write JavaScript. I like JavaScript. I know JavaScript very well. And I like NPM. So it's a go. It's good. There you go. You knew it was coming. But it's there all the same, You can call me on my cell phone. Anyway, so naturally, when one's looking to do something in JavaScript, in Node.js these days, you check out NPM, what's out there, what saves me time. I don't want to do too much reading. I found Fuse bindings. This is by far the most feature-complete NPM package. It can do most of the stuff that Fuse can do. How does it work? Those 3 lines. Hey, get me the module. Here on the system that I have, I want to mount this volume, and then mount it on that path, please. So in your working directory, you basically say, mount this virtual drive here, and let's work from that as if it were a file system. That second bit, and then you get this. You get a nice little OXX Fuse volume 0. It looks like a networked drive, okay? So the second argument of the Fuse.mount bit is where you say to it, for each action you try to do, or that the system tries to do, here's what I want you to run, here's a function I want you to run. So if you were just doing a read-only file system, which we're going to talk about right now for reasons we'll get to in a second, you have to have a read directory, get attribute, open, and read function, which will give you a read-only operating system you can hijack and do things with. So, disclaimer, for this demo, I used AWS S3, which as an IBM developer advocate with cloud storage offerings, I should not have done. But it was a hack day. I had credentials lying around, and I thought, right, screw it, let's just go for it anyway. So, sorted, right? Sound effect. There we go. So read directory, that's the first one we're going to go through. I've got a minute to go through. Very simply, it's just like, hey, what's in this directory? I need a list of files and things. So very simple, S3, list objects, what's in here, cool, return an array. Next up, you have get attribute. So this is called every time the operating system wants to know about a file. So it's like, hey, how big is this file? What does it do? What are the permissions? And so, that's a little harder. You have to do a head object for S3 there. So you're saying to it, go to the cloud, find me these things, and then report it back. You'll see that there's a lot of new dates in there. I couldn't be asked passing in timestamps. Who wants to do that anyway? And moments, massive for a proof of concept. Open, this is the simplest one. It's saying, hey, I'm the operating system. I want to open this file. Tell me about it. So it gives you a file descriptor. So you just say, CB, okay, this module's not great when it comes to readability. But you're saying, hey, here's a file descriptor. Have at it. And finally, the hard one. Read. This one looks very simple. Get me the data. Get me the bytes within a range, right? But because there's very little documentation, because it is basically written for C++ developers, I had no idea how any of this worked, which meant it was basically me just having a go at it and crying for a day, trying to figure out what the hell you do. Basically, you get past a buffer that you can't reassign, you can't pass back a new buffer, you have to write the data with a 0 offset, as if it were offset, but it's not, from the result that you get from the S3 buckets. So that's it. That's what you basically need to get an S3 cloud object storage, pretending as a hard drive. There we go, 10 seconds, right? Cool, and here's a demo, which always goes fantastically well. Oh, no, it's not working. Right, so run the Node.js app. Yay, okay, hey, it's working. That never happens in the live demo. Here we go. The suspense is killing me. There we go. So you get this lovely little drive there. I'm going to click on it. Okay, for the volume. Also, have you seen the Wi-Fi speeds here? They're incredible. Do a speed test. My God. So that's my S3 bucket, but it acts just like a normal hard drive. If I double-click this, I don't get previews. I don't know what it is yet. If I double-click Edinburgh, it's going to take a second to think about it because, again, I'm hijacking what the operating system wants to do. But there it is. That's from the cloud, not my hard drive, but it was treated exactly like a native file. And that's basically it. Takeaways, this is hard. I don't advise this. It's hard because there's little documentation, but that's no one's fault. There's a lot of things that Fuse can do, and no one's sat down and done it yet. I hope to make it simpler in time. And finally, the operating system is not like being effed with, all right? If you try and do something and you don't do what the file system is expecting you to do, it stops. It's quicker to reboot my Mac than for Finder to figure out what the hell's going on, which is why I've restarted this thing 20 times in this office today. And that's basically it. That's me. That's what I do. And if you have any questions, come and find me afterwards. Sorry about running over.